The simulation hypothesis. Are we living in code? Right now, I want you to take just a second and focus on exactly what you're experiencing. You're breathing, your heart is beating, your brain is effortlessly processing the exact frequency of my voice. It all feels so absolute, doesn't it? It feels incredibly real. But in today's explainer, I want to start us off with a thought experiment that challenges the very foundation of those sensations. What if every single piece of data entering your senses right now, the sights, the sounds, the feeling of the chair beneath you, isn't coming from a physical world at all? What if instead, all of it is being streamed to you from a server rack sitting in some unimaginably advanced laboratory?
What if everything you feel is just data from a server rack? Now, I know exactly what you might be thinking. You're probably picturing a sci-fi trope straight out of the Matrix, right? But what we're exploring today is something far more grounded and, frankly, a lot more staggering. This concept is a legitimate, heavily debated mathematical dilemma. It's an idea that literally keeps modern astrophysicists, cosmologists, and philosophers awake at night. We aren't talking about science fiction today. We're talking about theoretical probability.
And that brings us to our core definition, the simulation hypothesis. It's a mathematical dilemma proposing that our reality is actually a simulated virtual environment created by a more advanced civilization. What's really interesting here is where the modern obsession with this idea actually comes from. It traces directly back to a definitive paper published in 2003 by a philosopher named Nick Bostrom. Bostrom completely changed the conversation, basically shifting it from philosophical musings straight into the realm of hard logic.
Bostrom's trilemma, a strict probability framework. See, Bostrom didn't just throw a random guess out into the dark. He developed a strict probability framework. He argued that any advanced civilization will eventually reach a post-human stage. And at this post-human stage, a civilization would possess computational power so vast it's entirely beyond our current human comprehension. With that kind of processing muscle, running what he called ancestor simulations, which are highly detailed virtual realities populated by fully conscious coded beings, would be as trivial to them as playing a simple video game on your phone is to you.
He laid it out in 3 steps. 1. Extinction before the post-human stage. 2. A loss of interest in running simulations. 3. We are almost certainly simulated. Bostrom mathematically proved that one of these 3 specific options absolutely must be true. Either species always go extinct before reaching this advanced stage, or they reach it but lose all interest in simulating their ancestors, or we are almost certainly living in a simulation right now. Why? Because if these simulations do exist, the number of virtual, simulated minds would outnumber organic, biological minds by 1 billion to 1. Just purely on statistics alone, if option 3 is true, the odds dictate that you are the code, not the original creator.
And this brilliantly illustrates why that third option feels so incredibly plausible. We're comparing technological eras here. On the left, you've got 1970s Pong, literally just 2 white lines and a bouncing dot. On the right, ultra-realistic modern 3D game engines with photorealistic AI. Just think about that. That is a massive technological jump in just half a century. 50 years from 2 lines on a screen to sprawling open worlds reacting in real time. Project this exact curve 10,000 years forward. Seriously, take that incredible 50-year leap in computing we just talked about and project that exact same curve into the future. Not 50 years, not 100, but 10,000 years. On a cosmic scale, 10,000 years is literally a fraction of a second. Imagine the computing power we'd have. At that point, simulating an entire universe down to the atomic level wouldn't just be possible for us, it would be practically inevitable. 300,000 kilometers per second, which leads us to look at our own universe with a bit of suspicion, honestly. When you start examining the fundamental rules of our reality, you start to see things that look suspiciously like programming constraints. Take the speed of light, roughly 300,000 kilometers per second. Why does our universe have a hard, unbreakable speed limit? Why are we physically throttled at this specific number?
The universe's maximum processing limit. To a simulation theorist, that speed limit is incredibly revealing. It isn't just an arbitrary, random rule of nature. Instead, they view it as a strict hardware limitation. Just like your computer has a maximum processing speed, 300,000 kilometers per second is the maximum processing speed of our universe's central processing unit. The simulation engine literally cannot render reality any faster than that. Think of it as the universe preventing a massive lag spike by capping the frame rate. The physics of our universe are capped.
Planck length. The absolute smallest scale of reality where space and time break down into finite, discrete, individual blocks. Okay, let's dive into this because it gets even stranger when we look at the fabric of space itself. Have you ever heard of the Planck length? If you zoom all the way down past cells, past atoms, past quarks,
space and time actually stop being smooth and continuous. Instead, reality becomes discrete. It breaks down into tiny, finite, individual blocks. Put simply, the universe, at its absolute foundational core, is pixelated. And if the fabric of our reality is built out of individual, rigid pixels, well, it strongly implies that it was designed to be computed.
The boundary of energy. Okay, so up to this point, the simulation hypothesis sounds incredibly convincing, right? I mean, the statistics make sense, the tech curve aligns perfectly, and our universe literally has a speed limit and pixels. But this is exactly where the hard laws of physics fight back. And they fight back hard. We have reached the boundary of energy. And this is where the simulation argument starts to face massive, perhaps insurmountable, scientific roadblocks. Listen to this. To simulate just the quantum variations of the planet Earth, you would need a computer that requires more energy than exists within the entire visible universe. A groundbreaking study published in the journal Frontiers in Physics took a really hard look at the fundamental relationship between information and energy. These astrophysicists sat down and calculated the exact, literal thermodynamic cost required to compute the infinite, chaotic quantum states of just a single macroscopic object. The result completely breaks the simulation theory. You would need more energy than exists in the visible universe just for Earth alone.
Gödel's incompleteness theorem and quantum gravity. And the pushback from physics doesn't stop with just the energy requirements. It also extends deep into the realm of mathematics. Recent research has taken Gödel's incompleteness theorem, which is a famous mathematical proof about the limits of provability, and applied it directly to the theories of quantum gravity. This research essentially aimed to see if the foundational laws of our reality could even be written as a computer program in the first place.
The findings highlight a fundamental mismatch. We're comparing algorithmic logic with non-algorithmic mechanics here. By definition, any computer simulation, no matter how ridiculously advanced it is, must run on algorithmic logic. It absolutely requires programmed step-by-step mathematics to function. But our specific universe, it operates on non-algorithmic mechanics. It relies on chaotic quantum phenomena that fundamentally cannot be reduced to step-by-step code. Standard programming physically cannot replicate it.
The simulation hypothesis collapses under its own weight. So, what's the big takeaway here? Logically, this specific universe cannot be a simulation running on any machine we can mathematically conceive. Unless the advanced entities supposedly running our reality operate on totally alien laws of physics that are completely detached from the logic of our own universe, the hypothesis just collapses under its own mathematical and thermodynamic weight. The energy cost is simply too high, and the quantum mechanics are just too unprogrammable.
Reality is real, it is heavy, and it belongs entirely to you. Honestly, I think this leaves us with a deeply empowering synthesis. The universe isn't a computer program running on some cosmic server rack. That pixelation at the Planck length, it isn't digital code. The speed of light isn't a processor bottleneck. And the reality you are experiencing right now, the air you're breathing, the ground you're standing on, isn't a glitch in a matrix. It's real, it's wonderfully heavy, and it belongs entirely to you.
Since reality is far too complex for code, what infinite, unprogrammable mysteries are waiting for you out there in the real world? We've seen how the absolute grandest theory of virtual reality completely falls apart when it's tested against the awe-inspiring complexity of actual physics. So I want to leave you with this final thought. Since our reality is mathematically proven to be far too complex, too chaotic, and too beautiful for mere code, what infinite, unprogrammable mysteries are waiting for you to discover out there in the real world? Keep questioning, keep exploring, and thanks for joining me for this explainer.